All right, so here's question number 9. Fairly easy question, although could be lengthy, but conceptually it's not that difficult. So let's see what it says. It says the equation, so 3 upon x plus 5 minus 2x plus c, where c is a constant, has no real roots. Okay, so these are the key words. No real roots basically means that b square minus 4ac has got to be less than 0. Find the range of possible values of c. Okay, now before I can sort of plug in the values in a, b, and c, I need to first cross multiply and make a quadratic equation out of it. So first let's just copy paste the equation. So we have 3 upon x plus 5 is equals to minus 2x plus c. Okay, so what I'm going to do is I'm going to multiply both sides of the equation by x. Okay, so it's like taking the LCM and then multiplying, except that we're skipping the LCM part. It's not like we're not taking the LCM, it's just that we are multiplying both sides by x, and that way automatically you can skip the LCM part. So this becomes 3 plus 5x is equals to minus 2x square plus cx. Okay, let me just write this nicely. Minus 2x square. Okay, now let's get all the, let's write it like a quadratic equation should look like. That is x square first, then all the x's, and then the constant. So I'm going to move minus 2x squared to the left hand side so that it can be positive. So minus 2x squared plus cx minus, 2x squared plus 5x, since that's already positive, minus cx plus 3. So we've moved all the terms to the left hand side. Okay, and now let's factor x, meaning let's take x common. So now you can see that it's starting to look like a quadratic equation, meaning that we can actually compare it with ax squared plus bx plus c, and we will have the value of a, b, and c. So a is equals to 2, b is equals to 5 minus c, and c is equals to 3. Now no real roots, as I mentioned earlier, means b squared minus 4ac is less than 0. So 5 minus c, the whole thing square, minus 4 times 2 times 3 is less than 0. Okay, now you can solve this by expanding, but in a situation like this I wouldn't recommend that, because you can actually take advantage of the fact that you don't have any unknown here and that you have a whole square here. So here's what I'm going to do. I'm going to do 5 minus c, the whole thing square, minus, now 4 times 2 is 8, 8 times 3 is 24, so minus 24 is less than 0. So that means 5 minus c, the whole thing square, is less than 24. Okay, now for a second, because ultimately we want x-intercepts, right? And then we're gonna make a quadratic curve, and then we're gonna write down the range. Okay, so for a second, let's assume that this is a quadratic equation instead of a quadratic inequality. So how would you solve it? You would solve it by taking the square root on both sides so that you can get rid of the square. Okay, and when you do that, so you have 5 minus c, and the square root of 24 will actually be equal to 2 under root 6. You can use your calculator. Okay, and don't forget the plus minus. Okay, so let's make c the subject. So c would be equal to 5 plus minus 2 times square root of 6. Okay, now this is basically, now because it's a quadratic inequality, okay, and because it's a quadratic inequality, that means it will have, and since we have two values of x, okay, now by x I mean c, so that means there are two x-intercepts. Okay, and one thing you should be careful of is that they're both positive. 5 minus 2 under root 6 and 5 plus 2 under root 6, they're both positives. Okay, so that means one is probably somewhere over here. This will be 5 minus 2 under root 6, and the other is 5 plus 2 under root 6. That means what we're looking at is basically a quadratic curve which cuts the x-axis at 2 points. Okay, and here are the 2 points. Now, we were not supposed to solve a quadratic equation, we were supposed to solve a quadratic inequality, and the inequality was basically less than 0. Okay, so less than 0 means that which part of the curve do we want? We want the part of the curve that's below the horizontal axis. Okay, so for that, the range of c, okay, so just replace c with x. Okay, so the range of c, or the range of x, must be 5 minus 2 under root 6. Okay, it must be greater than that, and it must be less than 5 plus 2 under root 6. And that's it. That is your final answer. Okay, so like I said, it was lengthy, but conceptually not that difficult. Okay, but you have to make sure that you have a good grip on quadratic inequalities, otherwise obviously you'll mess it up.